is there, Divya is there. Don't worry, I think it will calm things. Right? Okay. Take it. Long time, huh? So in the last class, we were discussing about the concept of pressure belt. We discussed different type of pressure belt. And then we discussed the concept of winds. What are the factors that are affecting the winds? Those parts we have covered. And we have classified wind into three major types. One was permanent wind, another was secondary wind, and the third was local wind. So we have discussed the permanent wind, which were trade winds, that is northeast trade wind, southeast trade wind, then you have westerlies and easterlies. So those are the four classification we have discussed with regard to permanent wind. And we discussed westerlies are more stronger in which hemisphere? Westerlies are more stronger in which hemisphere? They are more stronger in southern hemisphere, where they are referred as what? Where they are referred as what? Roaring 40s, furious 50s, and shrinking 60s. Okay, so those are the terms we have used: roaring 40s, furious 50s, and shrinking 60s. Fine. We also discussed the concept of pressure belt. So which pressure belt is known as a doldrum? Which pressure belt is known as a doldrum? Equatorial low pressure belt. Yes. Which pressure belt is known as a horse latitude region? Subtropical high pressure belt. Yes. Fine. Which pressure belt generally sees the formation of the deserts? Which pressure belt generally sees the formation of hot deserts? Hot deserts. Subtropical high pressure belt. Yes, subtropical high pressure belt sees the formation of hot deserts. Fine. So we discuss anticyclonic conditions are there, and that's why you'll see formation of hot deserts. Fine. So we'll start now with what? Now with the secondary wind concept. So we have divided the secondary wind into two types, which were seasonal wind and periodic wind. So we have discussed this is divided into further, that is mountain and valley breeze. And this part we have divided into what? This part we have divided into the sea and land breeze. And the third is your local winds. Local winds, broadly we classified into two types, that is cold local wind and warm local wind. So now we'll start with these winds, that is seasonal wind, periodic wind. We are going to start with these winds. Fine. So the first we'll take up is a seasonal wind. So last class we discussed the pressure belt. What are the extension of pressure belt we have discussed? Yeah, equatorial low pressure belt is extending from 10° north to 10° south. Then yeah, subtropical high pressure belt extension is how much? 23.5 to 35. Yes. Then subpolar low pressure belt region. Yes, this region we have discussed from where to where? From 45 to 66.5. And lastly we have discussed is what? Polar high pressure belt, that is from 80 to 90. So this same thing is repeated in the southern hemisphere also. So this concept of pressure belt we have discussed, and we discussed along this which trade winds are there. Northeast trade wind. Along this what is there? Westerlies are there. And along this what is there? Easterlies are there. So those winds also we have discussed. Now when there is a variation in pressure belt, what is going to be formed? Seasonal winds are going to be formed. When there is a variation in pressure belt, what is going to be formed? Seasonal winds are going to be formed. Clear? So what is a seasonal wind? Basically, seasonal winds. These winds blows in a particular season. And is formed due to shifting of pressure belt. Fine. So these wind blows in a particular season and is formed due to shifting of pressure belt. The shifting of pressure belt occurs due to apparent movement of sun in respect to earth from Tropic of Cancer to Tropic of Capricorn. From Tropic of Cancer to Tropic of Capricorn. Fine. So seasonal winds are those winds which blows in a particular season. They blow in a particular season and it's formed due to shifting of pressure belt. The shifting of pressure belt occur due to apparent movement of sun with respect to earth, and sun moves between what to what? Tropic of Cancer to Tropic of Capricorn. So that is what? Apparent movement of sun with respect to earth. Fine. Now assume this is your equator region. This is nothing but your Tropic of Cancer region, and this is your Tropic of Capricorn region. Fine. Now so this is how you'll find Africa continent. Here you'll find what? Here you'll find India extending like this. This is how you'll find extension of India. This is how you'll find extension of Australia. Fine. Australia is something that is how it is passing through. This is where Arabian region, Arabian plateaus you are going to find. This is how Arabian plateaus you are going to find. And this is where Pakistan is lying and your Iran is lying. So this part is your Iran. Fine. So as we discussed, normally what is the position of what is the position of equatorial low pressure belt? Generally between what? 10° north to 10° south. What is the position of equatorial low pressure belt? 10° north to 10° south. So what is 10 degree north to 10 degree south means? This is equator region. This is equator region. So extension should be between this. This is the extension of extension of equatorial low pressure belt, that is 10 degree north to 10 degree south. Fine. But when the sun position shift over here, when the sun position shift over here, generally when sun position shift over here, when the sun is a tropic of Cancer, summer solstice, yeah, okay, it is at summer solstice, sun is over here, which is generally around 21st June. So we discussed when sun is overhead at what? When sun is overhead at Tropic of Cancer region, which region is going to be more heated? Tropic of Cancer is going to be more heated than equatorial region. Clear? So equatorial region will get less heated because here slanting rays are coming, here direct rays are coming. Remember, we discussed the heating is due to more due to direct rays rather than slanting rays. So what you see is equatorial region is going to be less heated. When equatorial region is going to be less heated, what you see is shifting of pressure belt is going to be occur. Shifting or pressure belt is going to occur. And what you see is the equatorial low pressure belt will slightly shift upward. So this is equatorial low pressure belt, which generally used to form over here. This is 10 degree north to 10 degree south, generally will shift upward. Equatorial low pressure belt will shift upward. Fine. So this is extension of equatorial low pressure belt is going to be there. Clear? So as a result, what you are going to find is what you are going to find is you're going to find all pressure belt are going to shift upward. All pressure belt are going to shift upward. So let's say this is there. Now equatorial low pressure belt is slightly shifting upward. So what will happen to subtropical high pressure belt? It will also shift upward. What will happen to subpolar low pressure belt? It will also shift upward. And what will happen to polar high pressure belt? This will also shift upward. This is equatorial region. So all pressure belt will shift upward. Why it will shift upward? Because sun position is what? Sun position is at Tropic of Cancer. Correspondingly, what will happen to here? Here you will see polar high pressure belt will extend. You know that 6 months of days and 6 months of night in polar region. Then what will happen? Here you will see subpolar low pressure belt. And here you will see what? Coming of subtropical high pressure belt. So the pressure belt will become more bigger in the southern hemisphere. They will become more narrower where in the northern hemisphere. Okay, they will become more narrower in the northern hemisphere. They will become more bigger in the southern hemisphere. So they will become more bigger over here, and they will become more narrower over here due to shifting of what? Shifting of pressure belt. Fine. So this is what occurring when sun position changes. When sun position shift from equator towards Tropic of Cancer, the Tropic of Cancer will receive more amount of sunlight. So Tropic of Cancer will receive more amount of sunlight. Then what will happen? Then equatorial low pressure belt is going to shift upwards. So correspondingly, what will happen to subtropical high pressure belt? Will shift upward. Subtropical high pressure belt is going to shift upward. This is also shifting upward. And what will happen to subtropical high pressure belt over here? It will also come over here. So subtropical high pressure belt is also going to come over here. So that is what, okay, you are finding. Clear? Now you know that this equatorial region is a meeting point of whom? This equatorial low pressure belt is a meeting point of which two wind? No, it is a meeting point of northeast trade wind and southeast trade wind. Equatorial low pressure belt is a meeting point of which two wind? Northeast trade wind and southeast trade wind. It is a meeting point of these two wind, and as a result, we call it also as what? We call it as also as what? ITCZ. What was ITCZ? What was ITCZ? Intertropical Convergence Zone. What is ITCZ? It is Intertropical Convergence Zone. Remember, we discussed equatorial low pressure belt. Last class we discussed it is also known as a doldrum. It is also known as what? ITCZ. Why ITCZ? Because it is a converging zone of whom? Converging zone of northeast trade wind and southeast trade wind. Fine. So it is a converging zone of northeast trade wind and southeast trade wind. That's why it is also referred as what? It is also referred as a ITCZ. Fine. So now what is happening is what? Now what is happening is, assume the wind. Now northeast trade wind will blow like this. This is how northeast trade wind will blow like this. So northeast trade wind is blowing like this. From where to where? From subtropical high pressure belt to equatorial low pressure belt. You know that wind moves from where? High pressure to low pressure. So from subtropical high pressure belt to this wind is something that is okay blowing. And which wind will blow from here? Which wind will blow from here? We discussed this wind is called as what? Wind is called as a southeast trade wind. So this is northeast trade wind and this is southeast. So this is northeast trade wind and this wind is called as a southeast trade wind. So southeast trade wind is coming like this and northeast trade wind is going like this. Fine. Now this is where 0 degree equator is there. This is line as we are representing is 0 degree equator is there. Fine. Now what will happen when this wind will cross the equator? Now this wind has to reach where? Southeast trade wind has to reach where? Southeast trade wind has to reach where? It has to reach to equatorial low pressure belt. Why? Because we discussed meeting point of what? Meeting point of northeast trade wind and southeast trade wind are equatorial low pressure belt, and this low pressure belt zone is referred as what? Zone is referred as a intertropical convergence zone. So wind are converging at which zone? Wind are converging at equatorial low pressure belt. Fine. So now this wind has to reach where? This wind has to reach to this region, equatorial low pressure belt region. So this wind which is now blowing in southern hemisphere has to move into what? Northern hemisphere. Now you know that due to Coriolis force, winds are deflected towards which side? Due to Coriolis force, winds are deflected towards which side in northern hemisphere? Which side in southern hemisphere? Northern side. Yeah, northern hemisphere, due to Coriolis force, winds are deflected towards what? Right hand side. And we discussed in southern hemisphere, wind are deflected towards what? Left hand side. So in southern hemisphere, winds are deflected towards left hand side. In northern hemisphere, winds are deflected towards right hand side. Clear? So earlier, this wind was deflected towards left hand side. We discussed this is how we are moving. My left is this side. So that's why wind was deflected towards left hand side. But now when this wind will cross the equator, what will happen? It has to shift towards right hand side. So this southeast trade wind now will become what? This southeast trade wind will become southwest because it is now deflected towards right hand side. The southeast wind is now going to become what? Southwest wind, because the wind are deflected towards right hand side. So wind deflected towards right hand side. Wind deflected towards right hand side in northern hemisphere. So the southeast trade wind is now becoming what? Southwest wind, and the southwest wind is blowing over this region. So this is how southeast wind will reach towards what? Equatorial low pressure belt region. Fine. Now when the southwest wind is blowing over Indian Ocean region, this is Indian Ocean region, Arabian Sea region, Bay of Bengal region. So when it will blow over Indian Ocean region, what will happen? What will happen to these wind? It will carry moisture. It will carry what? Moisture. They will pick up moisture, and this moisture will cause rainfall where? In the South Asia region, or in case of Myanmar, in case of China, in case of Indonesia, this wind is going to cause rainfall, and that's why we discussed we have monsoonal wind. Our monsoonal wind is known as what? Our monsoonal wind is known as which type of wind? Southwest monsoonal wind. So in India, the rainy season occurs when to when? Rainy season occurs when to when? We discussed June to September is the rainy season in India. Why this rainy season is occurring in June to September in India? Because of which type of wind? Southwest monsoonal wind. So you know that at June, sun position is shifting over here. In the June, sun position is shifting over here. As a result, equatorial low pressure belt will shift upward. When shift upward, then southeast trade wind has to cross the equator and reach towards nothing but equatorial low pressure belt. When it will cross the equator, it will be deflected towards which side? Right hand side. Due to which force? Due to Coriolis force. And as a result, southeast trade wind will become what? Southwest monsoonal wind, and this will pick up moisture as well as causes a rainfall. Fine. So that's why this is called as what? This is called as a seasonal wind. Why it is called as a seasonal wind? Because it blows in a particular season between June to September. Fine. It blows in a particular season between June to September. Now, when sun comes back to the equator, at which time sun comes back to the equator? When equinoxes occur? Spring equinox and autumn equinox, two type of equinoxes we have discussed. So when spring equinox occur? September 23rd is autumn equinox and 21st March is what? Spring equinox. So by the time of 23rd September, what will happen? Sun will come back to this position. By September, sun will move back from here to here. When sun move back from here to here, what will happen? What will happen then? Then equatorial low pressure belt will shift where? At the equator part. They will again shift back to the equator part. When it will shift back to the equator part, what will happen? Southeast wind now not have to cross the equator. When they don't cross the equator, what will happen? They'll not become southwest wind, and as a result, what will happen? This wind will stop in what? This wind will stop in the month of September. That is okay there. Clear? Any doubt regarding this one? So what is happening is, why this seasonal winds are formed? We have written seasonal winds are formed due to apparent shift in the sun position, and it is happening due to what? It is happening due to shifting of pressure belt. So when sun shifted from here to here on 21st June, what you see is equatorial low pressure belt will shift upward. When it will shift upward, what will happen? The southeast has to cross the equator to reach to equatorial low pressure belt region. As a result, what will happen? Shifting of pressure belt will, as a result, deflection of wind will occur, and the southeast will become southwest monsoonal wind, when it will pick up moisture and causes rainfall in case of India. Fine. Any doubt regarding this part? And as we discussed, by the September, suns will come back to its original position. When it will come back to original position, equatorial low pressure belt will also come back to its original position. Now the southeast don't have to cross the equator. When they don't have to cross the equator, they will not get deflected and form what? Southwest monsoonal wind. And that's why monsoonal season stops in India by when? By nothing but September. So this is a reason why you see most of India's rainfall happens in the monsoonal region. So one type of seasonal wind we have discussed is what? We have divided the seasonal winds are of two types. What are the two types we have written? Southwest and northwest. We have written these two type of, last class we discussed two division of what? Two division of seasonal wind, southwest and northwest. Clear? So this is diagram you are finding with regard to what? Southwest. This is diagram you are finding with regard to southwest. Now we are coming to the northwest. So again, assume the same thing. This is your equator region, Tropic of Cancer region, and Tropic of Capricorn region. Fine. So this was Tropic of Cancer, this was equator, and this was Tropic of Capricorn. We discussed what will be the sun position when the sun is overhead at Tropic of Capricorn? Winter. That is 22nd December. So by September, sun will be over here. Then again, what will happen? Sun will move, apparent position of sun will shift towards here. When sun position shift over here, what will happen? Which region is going to get heated more? Tropic of Capricorn is going to get heated more as compared to equator. So again, what will happen? Shifting of pressure belt will occur. So now equatorial low pressure belt will shift where? It will shift over here. So this region, equatorial low pressure belt will shift. And as we discussed, this region, what will form? Subtropical high pressure belt. Subtropical high pressure belt is going to form over here, and here what is happening? Subtropical high pressure belt are going to be formed. So high pressure belt is going to be formed like this. Fine. So now what is happening is, if you remember this diagram, now when the sun was at the when the sun was at nothing but here, that is Tropic of Cancer, you see up shift pressure belt was shifting upward. But now when the sun position is at Tropic of Capricorn like this, then what will happen? You see here what will happen in southern hemisphere, you will see the narrowing of belt will occur. So this is equatorial low pressure belt. This will become what? Subtropical high pressure belt. This becomes subpolar low pressure belt. And this becomes polar high pressure belt. While here what of pressure belt will occur. So subtropical high pressure belt, you'll see subpolar low pressure belt, and here you'll see polar high pressure belt. Fine. So opposite condition is now occurring. So here earlier it was broadening one, now it is broadening when sun position is what? Sun position is at tropic of what? Sun position is at Tropic of Capricorn. Fine, any doubt? So now in this situation what will happen? In this situation now what will happen? As we discussed, which wind blows here to here? Which wind blows here to here? Yeah, southeast trade wind. So it will blow from here to here, southeast trade wind. And which wind is coming from here? Northeast trade wind. Northeast trade wind is coming. Now what will happen? Now northeast wind, in order to reach to what? Equatorial low pressure belt, because this is a convergence zone of northeast trade wind and southeast trade wind. So this has to now cross the equator. Now if this cross equator, which side it will be deflected? Towards the left hand side. So okay, the wind will be deflected now towards left side. So what will happen? This northeast will become which type of wind? It becomes a northwest wind. It becomes which type of wind? It becomes northwest wind. Fine. So this northeast will become northwest due to deflection towards left hand side in southern hemisphere. So it becomes a northwest wind. Now when this northwest wind will pick up moisture, what will happen? Because it is blowing over oceans, Indian Oceans region, when it will pick up moisture, what will happen? It will cause rainfall where? In the Australia, in the South Africa, in those regions you will see certain rainfalls are going to happen. So that's why it is called as a northwest monsoonal wind. It is referred as which type of wind? Northwest monsoonal wind. Fine. Clear? Now again, sun will come back to its original position when? So at 22nd December, sun is over here. Again, sun will come back to its original position when? At the 21st of March, the sun will again shift towards equinoxes. So when equinoxes is occurring, equatorial low pressure belt will shift upward. When it will shift upward, what will happen? What will happen? Now the wind don't have to cross the equator. So now the wind will not cross the equator. So what will happen? This northwest monsoonal wind will not blow. So generally it is blowing in which season? Northwest monsoonal wind is generally blowing in the month from November to generally Feb, or November, December to Feb. Generally you see blowing of northwest monsoonal wind in such particular season. Clear? By the March, sun will again be back to the equator. So this wind will be stopping. This wind will be stopping. Fine. So when it blows, generally it blows in November, December to February. We'll generally see blowing of what? Blowing of this type of wind. Fine. So this shifting of pressure belt is causing what? This shifting of pressure belt is causing the creation of what? Creation of two type of wind. One is called as a southwest monsoonal wind. Another is called as a northwest monsoonal wind. Since these wind blows in a particular season, that's why they are referred as what? They are referred as a seasonal wind. That's why they are referred as which type of wind? Seasonal wind. Fine. So now we are coming to the second type of secondary wind. which are referred as a periodic wind. So one type of secondary wind we have discussed is a seasonal wind. Second type of secondary winds are your periodic winds. So what is periodic wind? Wind that repeat itself, the wind that repeat itself after a certain period, the wind that repeat itself after a certain period of interval and reverses their directions periodically are referred as periodic wind. So wind that repeat itself after a certain period of interval and reverses their direction are referred as what? Are referred as a periodic wind. Fine. So last class we discussed periodic wind means like you have a periodic motion which repeats itself after a certain period of time and also reverses their direction. So that's how we call it as a periodic wind. And we discussed these are divided into further two types. First is what? Mountain and valley breeze. Mountain and valley breeze is the first type of what? First type of your periodic wind. So what is mountain and valley breeze? Fine. So this part is what? This part is referred as a mountain and this part is referred as what? Valleys. Now this we are taking up daytime scenario. What will happen during daytime? And this we are taking up at a nighttime scenario. What will happen during the nighttime? Fine. So you have two type of scenario, daytime scenario as well as nighttime scenario. During the daytime, what will happen? Let's say sunlight is like this. This mountain slope is going to receive more amount of sunlight. Clear? As compared to what? As compared to the valleys. Because over the valleys you have more atmosphere. More atmosphere means what? More refraction, more reflection will takes place. Clear? So during the daytime, what will happen? During the daytime, the mountain slope will receive more amount of sunlight. This will receive more amount of sunlight. This mountain slope will receive more amount of sunlight as compared to valleys. Fine. So when it is receiving more amount of sunlight, what will happen? We discuss anything which is okay receiving more amount of sunlight, what will happen? Will get heated. When heated, which type of pressure is going to be formed? Which type of pressure is going to be formed? If anything is heated, we discuss which type of pressure is formed. Low pressure. We discuss heating means what? Expansion. Expansion means which type of pressure is going to be formed? Low pressure. Okay, which type of pressure is going to be formed? Low pressure. Valley is not receiving much of sunlight. When valley is not receiving much of sunlight, what will happen to the valley? It cools down. If cools down, then what will happen? Which type of pressure is going to be formed? High pressure. Okay, valley cools down. So cools down means what? Contraction will happen. Contraction means what? Which type of pressure is going to be formed? High pressure. So as we discussed, wind blows from where to where? From high pressure region to low pressure region, and this is called as what? This is called as a valley breeze. This is referred as what? This is referred as a valley breeze. Fine, because it is moving from where to where? Valley to mountain. Remember, we discussed always winds are known from their point of origin. So what is origin point? Valleys are the origin point. So that's why this is referred as which type of breeze? Valley breeze. Now during night time, what will happen? During night time, what will happen? This mountain slope will lose heat quickly. This will lose heat quickly. Why? Why? Because less atmosphere is there. Less atmosphere means what? It will lose heat quickly. While you know that valley, whatever energy it will radiate, it will be absorbed by whom? Absorbed by the atmosphere. So what will happen? Valley will takes times to cool down. So during night time, what will happen? Valley will take times to cool down. Will take time to cool down, and mountain slope will lose heat quickly. So it will lose heat quickly. Now where the low pressure will be formed, where the high pressure will be formed? Yeah, low pressure at the mountain slope. We discussed when you are losing heat, cooling is happening. Cooling means which type of pressure is going to be formed? High pressure. Okay, so here cooling is happening. So cooling means high pressure is going to be formed. Here it is taking time to cool down. So what is going to be formed? Low pressure is going to be formed. Clear? So now what will happen? Wind will blow from high pressure to low pressure like this. So this type of wind is referred as what? This type of refer as a mountain breeze. This type of things are referred as what? Mountain breeze. Okay, so you have valley breeze and you have nothing but mountain breeze. These two type of breeze are something that are there. Again during daytime, what will happen? Again during daytime, what will happen? The direction of the wind will reverse, and what will happen? The mountain breeze, which is flowing in night time, will convert into what? Valley breeze during daytime. Again during night time, what will happen? This valley breeze converts into night time. So they are periodic wind repeating itself after day and night, and their directions are what? Their directions are reversing. Clear? Either you are seeing moving in the upward direction or you are seeing moving in the downward direction. So their directions are something that are also reversing. Fine. So that is why we have written what definition? We have written what definition? That wind that repeat itself after a certain period of interval and reverses their directions are going to be called as what? Are going to be called as a periodic winds. Fine. Clear? Now, last class, if you remember, we have used this term two wind. We have written one is katabatic wind and another is what? Anabatic. We have used this term called katabatic and anabatic also in the last class. We discussed which wind is known as a katabatic, which wind is known as an anabatic. Mountain and valley breeze is, we discussed, also known as which type of wind? Last class classification when we have written classification where we have written this two term also, no? Katabatic and anabatic. Clear? Chart where we did the chart, and there in the chart we have written katabatic also and anabatic also, no? So mountain and valley breeze, along with that we have written these are also known as what? These are also known as a katabatic wind and anabatic wind also. Clear? So the wind that is coming from mountain, wind that is coming from mountain towards valley is also known as which type of wind? Katabatic wind. It is also known as which type of wind? Katabatic wind. Well, the wind that is moving like this is called as a anabatic wind. Anabatic wind. Fine. So remember that descending air is called as which type of air? Which type of wind? Katabatic. Here wind are what? Descending. Here what is happening? Wind are moving up. So moving up, the wind that are moving up is referred as which type of wind? Anabatic wind. So wind that is moving up is called as an anabatic. The wind that is descending is called as what? Katabatic. Fine. So that is the term we also use, called as a katabatic as well as anabatic. Fine. Now that's why valleys are not very suitable for what? Valleys are not very suitable for agriculture. These are not very suitable for whom? Agriculture. Only certain crops we can grow in valley region. Only certain crops you grow in a valley region. Why? It is not very suitable for agriculture. Fine. Why it is not suitable for agriculture? Why do you think it is not suitable? For example, which type of things you are seeing, which type of cultivation you are seeing in Jammu and Kashmir or Himachal Pradesh? They are known for which type of cultivation? Apples, yes, okay. Saffron, yes. So those type of cultivation you are seeing more in case of Jammu and Kashmir. You're not seeing what? You're not seeing the wheat cultivation, rice cultivation, other cultivation. You're not seeing over there. More of apple cultivation, saffron cultivation, those things you are seeing. Why? Because it is not very suitable for whom? Not very suitable for cultivation. Why not suitable for the cultivation? What happens during the daytime to the valley? Valley has which type of pressure? High pressure. High pressure means which type of, okay, temperature is what? Temperature is colder in the valley. During the daytime, temperature is colder in valley. Fine. What is happening during the night time? During the night time, what is happening? Colder winds are coming towards what? Valleys. During the night time, what is happening? Colder winds are coming towards the valley from the mountain. So the excessive freezing occur in the valleys due to colder wind. Excessive freezing occurs in the valley due to colder wind, and that's why it is not very suitable for whom? Excessive freezing occurs in case of valley. That's why it is not very suitable for whom? Agriculture. Fine. So that's why only certain crops can be grown, which can tolerate what? Which can tolerate cold conditions, which can tolerate very cold condition, can tolerate the freezing condition. Those are things that are grown in the case of valley region. Fine.
Sir, does this high pressure and low pressure affect the soil of India?
Yeah, because soil contains moisture, no? Soil contains moisture. This moisture will get into what? Freezing part. When wind will come, what will happen? Temperature will drop, moisture will freeze. When moisture will freeze, what will happen? Water will not be available. When water will not be available, plant cannot absorb it. When plant cannot absorb it, what will happen to crops? They'll get destroyed. So only those crops that can tolerate large amount of what? Large amount of colder conditions, freezing condition, only they can survive. Okay, so that's why not very suitable for agriculture. Fine. Now the second type of periodic wind we have is what? Second type of periodic wind we have is the land and sea breeze. This is a second type of condition, land and sea breeze. Fine. Again, during daytime we are taking up, and during the night time we are taking up. Fine. During daytime, you know that what? Land is going to what? Land is going to be heated quickly as compared to what? Oceans. Oceans takes times to heat. So anything heated, which type of pressure is going to be formed? Low pressure. Anything, okay, what? Which is cooler, what type of pressure is going to be formed? High pressure. So a wind will blow from here to here, that is from high pressure region to low pressure region. Since it is coming from sea region, it is called as which wind? It is called as a sea breeze. It is called as a which type of breeze? Sea breeze. During the night time, what will happen? During the night time, land will lose heat quickly. It will lose heat quickly. Heat loss quickly happens. That's why it will cool down. Cool down means which type of temperature, which type of pressure is going to be there? Which type of pressure is going to be there? High pressure. While oceans will take times to cool down. It takes times to cool down. So what will happen? Here what will be formed? Low pressure will be formed. So now a wind will blow from here to here, which is going to be called as what? Which is going to be called as the land breeze. It is going to be called as which breeze? It is going to be called as a land breeze. So from when the wind is blowing from land towards sea, it is going to be called as what? Land breeze. When the wind is moving from sea towards the land, it is going to be called as what? It is going to be called as a sea breeze. Fine. Fine. So again, you see, it is reversing its direction. Again, it's see, it reversing its direction during daytime, like this wind is flowing, during nighttime like this direction is being reversed, and again they are repeated periodically after during daytime and during nighttime. After a certain interval they are being repeated, so that's why they are referred as which type of wind? Periodic wind. Fine. Harsha, not getting? Not getting. Remember that anything when it's heated, which type of pressure is going to be formed? Low pressure. Anything which is cools down, which type of pressure is going to be formed? High pressure. Based on that, you can analyze where high pressure and where low pressure will form. Fine. Now, what will happen during the daytime? What will happen during the daytime when sea breeze are flowing? When sea breeze are flowing, what will happen? It will carry moisture. Yes. It will carry moisture, and this moisture is going to be what? Going to be coming in coastal areas. So moisture laden wind will come in what? Moisture laden wind will come in coastal areas. Coastal areas. Fine. Now what will happen if moisture laden wind comes in coastal areas? What will happen? Rain will happen. Any other thing? If rain will not happen, then what will happen? If moisture laden winds are already there, wind carries more moisture. Let's say wind are coming, this wind carries more moisture. Already, you know that wind has a certain capacity to what? Certain capacity to hold moisture. Already, if it is having already moisture coming from the ocean, then what will happen? The wind cannot carry more moisture. So what will happen is evaporation will slow down. In coastal areas, what will happen? Evaporation will slow down. Clear? Coastal areas, what will happen? Evaporation will slow down. Why evaporation will slow down? Because wind already had the moisture. So wind do not require much moisture, or wind cannot hold moisture. That's why you see evaporation will slow down. Clear? How wind carries the moisture? Through evaporation. So if wind already has a moisture, then what will happen? Wind evaporation capability will decline. Fine. Let's say this is a wind. This is a wind. This wind, let's say 100% capacity is there. Out of this wind has already have 80% moisture. This wind already contain how much moisture? 80%. So how much maximum it can hold further? 20%. So what will happen is, okay, when it will come on the land side, what will happen? You'll see only 20% evaporation will be there. All evaporation will not be there. 100% evaporation will not happen. Only 20% evaporation will happen. Fine. So that's why evaporation process slows down. Clear? So when evaporation process slows down, what will happen? When evaporation process slows down, evaporation provides you cooling effect. Evaporation provides you which type of effect? Cooling effect. Remember that. Evaporation provides you which type of effect? Cooling effect. For example, let's say you are too much sweaty and you come and stand under the fan. What will happen? Huh? If you are too much sweaty, come and stand under the fan. What will happen? You will feel colder. Okay, why you will feel colder? Because whatever the moisture are there, whatever water, sweat water are there, they are going to evaporate. When they are going to evaporate, what will happen? Cooling effect is going to be there. So that's why what you see is, okay, when evaporation happens, cooling effect are there. Clear? But when moisture laden winds are coming, the evaporation is not much happening. Evaporation not much happening. So what will happen? Cooling effect will not be there. Cooling effect will not be there. That's why during daytime, when moisture laden wind comes in the coastal areas, evaporation decreases, and cooling effect is not there. That's why person feels what? Person feels more uneasy. Persons feels what? More uneasy. Like when you visit Chennai, you feel more humid condition, more sweaty conditions in Chennai. Why? Because evaporation is not happening. Why it is not happening? Because the sea breeze is coming during the daytime. When sea breeze will come, what will happen? Moisture is already there in the wind. When moisture is already there, what will happen? Evaporation will not happen. Cooling effect will not be there, and that's why you will feel a lot of sweaty. You will feel a lot of uneasiness during the daytime. Fine. During the night time, what is happening? During the night time, what is happening? the moisture, lead and wind are moving away. These are moving away. So what will happen? What will happen? More evaporation, more cooling effect during the night time. And that's why night in coastal areas are very good, very comfortable. Night in coastal areas are very comfortable because of, okay, the increase in evaporation. Fine. So daytimes are what? Uneasy generally in coastal areas. Why daytimes are generally uneasy? Due to less evaporation. Night times are generally more comfortable in coastal areas. It is because of what? Because of the moisture, lead and wind going, and as a result what will happen? You will see more amount of what? More amount of evaporation. Fine.
So how does wind affect evaporation?
Wind effect, more stronger the wind, more drier the wind, more evaporation is going to be there. Okay, more stronger and more velocity of the wind and more drier the wind. Drier wind means what? More capacity to absorb. Clear? Let's say you have a certain capacity. You can, how much water you can drink? Can you drink unlimited number of water? You will drink 1 glass of water, 2 glass of water. What will happen? After that, your stomach will get full. So what will happen? Like you have a limited capacity to absorb water. Like that, air also has a limited capacity to what? Absorb moisture. Clear? So when already air is having a moisture, air will not be able to further absorb the moisture. When it will not be able to further absorb, what will happen? You'll see evaporation will decrease. When air will have the capacity to absorb moisture, what will happen? Evaporation will increase. Fine, any doubt? So that's why you see when humidity is very high in the air, when you see humidity is going to be very high, then you see then you see more sweaty conditions and etc. When humidity is less, what will happen? You see more, okay, what? More evaporation. Then you see less of sweaty conditions. Clear? Any doubt regarding this one? So during daytime, the person generally feels uneasy in what? Generally feels uneasy in the coastal areas. During the night time, what will happen? Comfortable conditions are there. Fine. Any doubt regarding this particular thing? Evaporation majorly takes place near the, yeah, it takes in the water surface. That's why we are seeing the moisture laden winds are coming. Here evaporation is happening. That's why when wind is coming, it is carrying what? Moisture. Okay, it is carrying lot of nothing but, okay, moisture. That is okay there. But when it is coming on the land, what will happen? When it is coming on the land, what will happen? Since it already has a moisture, it is not absorbing what? Much moisture. It is not absorbing much moisture. You are also losing what? From your body also, what is happening? You are losing moisture. Why you are losing moisture? Why you are losing moisture from your body? Because of heat. Heat will, evaporation will happen. Okay, like that, plants are also losing what? Water. Transpiration. You have heard about the term transpiration. Plant loses water by a process called as a transpiration. Clear? So that's why plant also require water. You also require water continuously to drink. Why? Because you are losing water. So this losing water is going where? In the air. But when air already has a moisture, then what will happen? They will not be able to absorb it. When they will not be able to absorb it, what will happen? Evaporation will decrease, cooling effect will decrease. When cooling effect will decrease, you will feel uneasy. Fine? That is what conditions are there.
In summer as well, heat weather not. So
that is okay. The body way to maintain your body temperature. Osmoregulation process. It is called as a osmoregulation. So as you know that heat always flow from where to where? Higher body temperature to lower body temperature. Let's say your body temperature is how much? 37 degrees Celsius is your body temperature, or 98.6 degree Fahrenheit, whatever you are taking. This is your body temperature. Let's say atmospheric temperature is how much? Around 50 degrees Celsius. Summer conditions are there, 48, 49, 50 conditions are there. Now heat will flow from where to where? From atmosphere, and your body will absorb what? Your body will absorb heat, because heat is flowing from where? Higher body temperature to lower body temperature. When your body will absorb heat, what will happen? The temperature will increase from 37 degrees Celsius to what? 38, 39, 40. Your temperature will start increasing because heat transfer is taking place. Now, as you know that all your enzymes in your body works at a specific temperature. So body has to maintain this much temperature. So that is the reason why you start sweating. So that is the reason why you start sweating. Sweating, what will happen? As we discussed, sweat will evaporate. When sweat will evaporate, what will happen? Cooling effect will come. Cooling effect will come means temperature will drop. Okay, it will come, it is increasing to 38, 39, it will come down to 37. So that is the reason why you sweat. So it is a body way to maintain what? Body way to maintain a constant temperature. Clear? So sweating is a natural process that we undergo. It is a body way to maintain what? Maintain a constant temperature. This process is referred as a osmoregulations process in a body. Fine. So that is the reason. So that's why you are losing water. When you are losing water, what will happen? When you are losing water, what will happen? Cooling effect is there. Let's say you don't lose water. When you don't lose water, what will happen? Temperature of your body will increase, cooling effect will not be there, and as a result person will feel what? Uneasy. Person will feel uneasy. During the night time, what will happen? Comfortable situations are there. Fine. So that's why coastal areas, humid conditions are present. As a result, daytimes are uneasy, night times are more comfortable. This is happening due to which type of breeze? Land breeze and sea breeze. That's why there is another classification of wind that you can also do, that is called as, okay, what? That is called as a offshore wind and onshore wind. That is called as a offshore wind and onshore wind. There is another classification that you can have, offshore wind and onshore wind. So generally, wind that comes from what? The wind that comes from sea to land, like sea breeze. We discussed sea breeze is coming from where? From sea to land. Wind that comes from sea to land contain what? Moisture. So they can create a rainfall. When they have the moisture, they can create a rainfall. So such type of winds are referred as what? Such type of winds are referred as a onshore wind. Wind that can create rainfall. Wind that can create rainfall is called as a onshore wind, coming from where to where? Coming from sea to land. Wind that is coming from sea to land and can create rainfall is called as which type of wind? Onshore wind. Fine. Fine. And wind that moves from land towards sea will what? Will not cause rainfall, because on the land what will happen? On land evaporation is not going to be much. Such winds are dry wind, so they will not create a rainfall. So these dry winds are referred as which type of wind? Offshore wind. So wind moving from what? Wind moving from land towards sea, which is drier in nature, is called as what? Which type of wind? Is called as a offshore wind. Clear? So onshore wind will create rainfall, offshore wind will what? Not create rainfall. Fine. So these are called as what? These are called as your seasonal wind. These are referred as what? These are referred as a seasonal wind and periodic wind. Together we call seasonal and periodic as what? Secondary wind. Okay, together we call it as a secondary wind. Fine. But we are coming to the local winds. And we discussed local wind, we have divided into what? Warm local wind and cold local wind. Warm local wind, we discussed various types like Chinook, we've written Fawn, Zonda, Lu, Sirocco. Fine. So these are the warm local wind we have discussed in the last class. We discussed Gray, Bora, Mistral, Blizzard, Pampero. These are which type of wind we have discussed? Cold local winds. So these are warm local wind, while these are cold local wind that we have discussed. Fine. So what is these type of wind? The first thing, as we discussed, cold local wind means what? They are blowing in a specific region only. They are blowing in a specific region. That's why they are referred as what? They are referred as a local wind. Okay, they are not like seasonal wind which blows in a particular season throughout the globe. They are blowing only in a certain areas, and that's why it is referred as which type of wind? Local wind. Fine. And the first type of local wind that you are finding is Chinook. Now assumes this wind is which type of wind? Onshore wind. This wind is which type of wind? Onshore wind. We discuss onshore means what? Coming from where to where? Sea towards land. Now this wind is encountering a mountain onto the land. So this onshore wind which is coming is encountering what? Is encountering a mountain on a land. Then what will happen to these wind? What will happen to these wind? This wind will start to rise up. This wind will start to rise up as mountain is blocking the flow of wind. When mountain is blocking the flow of wind, what will happen to the wind? Wind will force to rise up. When wind will force to rise up, what will happen? We'll see clouds are going to be formed over here, and clouds are going to be formed, and what will happen? Rainfall is something that is going to happen in this region. Rainfall is going to happen in this region. And as we discussed, whenever condensation happens, which heat are being released? Whenever condensation happens, which heat are being released? Which heat are being released? Which heat are being released? Latent heat. Last class we discussed latent heat are being released whenever what? Condensation is something that is okay happening. So when latent heat are released, it is going to heat the wind further. When it is going to heat the wind further, what will happen? Wind has to nothing but okay further rise up. Now wind will come to this side of the mountain. Wind will come to this side of okay mountain. Yeah. But when this will come to this side of mountain, what will happen? It becomes a dry wind. Yes. So this was onshore wind, moisture laden wind, but it will lose all its moisture because of rainfall. And when wind will come over here, it becomes a dry wind. Fine. Now, you know that when you go up, what happens? As you go up, what will happen? Temperature will decline. When temperature will decline, wind temperature will decline. Wind temperature will decline means whatever moistures are there, they will condense. They will condense. And that's why this wind will become which type of wind? Cold wind. Because temperature is declining, the wind is going to become which type of wind? Cold wind. So it is at the top of the mountain, you are going to encounter which type of wind? Cold and dry wind. But when this cold and dry wind comes near to the surface, what will happen? As you are coming down, as height decreases, temperature will what? Increase. As you are coming down, what will happen? Temperature will increase. So wind that is coming on the other side of the mountain becomes which type of wind? Warm and dry wind. Because this cold wind, its temperature will increase as it comes down. Its temperature will increase as it comes down. Fine. As you are going up, temperature is decreasing. So as you are coming down, what will happen? Temperature will increase. So this cold wind will become which type of wind? Warm and dry wind. Fine. So this side of the mountain which experiences the wind onshore is called as what? Is called as the windward side of the mountain. This is called as a windward side of the mountain, and this side of the mountain which experiences the warm and dry wind is called as a leeward side of the mountain. Leeward side of the mountain. So this side of the mountain which experiences what? Which experiences the rainfall is referred as a windward. This type of mountain which is generally drier in nature, do not experiences rainfall, is called as what? Leeward side of the mountain. Fine. So this warm dry air is okay. Warm dry air is the reason why you see these three winds are something that are being created. Chinook, Fawn, Zunda. All are these type of wind only. They are created on the other side of the mountain. Chinook, Fawn, Zunda are created on where? They are created on the other side of the mountain, that is on leeward side of the mountain. All these three winds are created where? All these three winds are created at the leeward side of the mountains. Clear? Fine. So remember that whenever the onshore winds are going to come and blocked by the mountain, this wind will be forced to rise up. As you go up, temperature will decline, cooling and condensation will happen, which will release a heat. This heat will further expand the air, so air will further rise up. When air will come onto the other side, this cold and dry wind will become warm and dry wind as it descends. Clear? So warm and dry winds is going to come, it is going to descend to warm and dry wind, and this warm and dry wind causes the changes, and that's why you see what you see, these winds are created, which is Chinook, Fawn and Zonda. Fine. Any doubt regarding this one? So where these winds are created, so you know that this region we discuss in the USA, which mountain is over here? Rockies. Yes. Okay, we discuss Rockies mountains are there. So when wind is blocked by the Rocky Mountain, what will happen on the other side of Rocky Mountain? This is a windward side, this is a leeward side. So on leeward side, which type of winds are going to come? Warm and dry wind. So this warm and dry wind, when it is coming, it melts the snow. It melts the snow in this region. Because warm wind, hot winds are there. This hot wind will melt the snow in this region. That's why making possible agriculture. It makes possible cultivation. That's why the name is given as what? That is why the name is given as Chinook. Chinook means snow eater, one which eats the snow, called as a Chinook. Chinook itself means the snow eater. So when it comes onto the other side, when wind descends onto the other side, it melts the snow that are lying on the field. As a result, making possible the cultivation. Fine. So that's why the name that is given is Chinook. So Chinook is flowing where? In the North America. Chinook is flowing where? In the North America, on the leeward side of whom? On the leeward side of Rocky Mountain. Clear? Chinook is flowing in the North America on the leeward side of whom? Leeward side of Rocky Mountain. It is a good wind. Why it is good wind? Because it is melting the snow and ensuring what? Ensuring the agriculture cultivation possible. Fine. Now, which mountain is now over here? Andes. Yes. So on the leeward side of the Andes, which wind you are going to see? It is called as a Zonda. On the leeward side of Andes, which wind you are going to see? It is going to be called as a Zonda. So Zonda is blowing where? Zonda is blowing on the leeward side of the Andes. Again, this is going to what? This is going to melt snow, particularly in Argentina region and other region. Fine. Making possible some sort of rearing. Making possible some sort of rearing. If you remember plateau discussion, which plateau is lying over here? Which plateau is lying over here? In Argentina, which plateau is lying? Go back to the plateaus. Just see which plateau is lying in Argentina. Argentina, which plateau is there? We discussed something called Patagonian Plateau. Which plateau we have discussed? Patagonian Plateau. Read the characteristic of Patagonian Plateau. Read the characteristic of Patagonian Plateau. No one has written. Ship rearing. Yes, it is famous for ship rearing. And what is the thing? Any other thing we have written? That this plateau is what? This plateau is deserted plateau. We have written, okay, that the Patagonian Plateau is famous for what? Sheep rearing. And it is also it is a which type of plateau? Desert plateau. Why it is a desert plateau? Why it is a desert plateau? Lying on the leeward side. Leeward side we discussed, no rainfall will happen. When no rainfall, what will happen? What you're going to find? You're going to find deserts over there. Okay, so Patagonian desert also we have discussed. Desert class, we have discussed desert also. So why desert are formed on the, okay, form over here? Desert are formed because they are lying on the leeward side, that is okay there. Fine, any doubt? So that's why all things are connected. When you are reading reading the wind, just okay, remember that here lies which plateau? Patagonian plateau. Why Patagonian plateau is in desert condition? It is in desert condition because of what? Because of nothing but okay, the leeward side of the mountain, and that's why it is famous for which type of rearing? Sheep rearing. Colder conditions, sheep rearing can be done in this particular region. Fine. Sheep rearing means okay, the sheeps are there from where you derive what? Wool. Yes, okay, and that wool is used for cloth and other things. That is okay.
So how do they do that?
Okay,
Like,
they from the sheeps. Okay, they cut it.
But there is deserted area. So how do like sheep also live?
They survives in a okay a bit of desert condition. They require that type cold environment, desert conditions.
Okay.
That's why in Himachal Pradesh and etc. also you'll find that type of that. Fine. In fact, you have heard about something called pashmina. Pashmina, have you heard about the term pashmina? What is?
So that is a type of we found that in Ladakh area.
Ladakh area, yes, okay, and yeah, and it is used for making shawls, the woolen things and etc. So that also comes from that region. So these important things you have to keep in mind. Fine. And so we have done Chinook, we have done okay what? The Jonda. Another important we have written is fawn. Now fawn where you are going to find. Now this is where your which region? Which is there? African. And this part we discussed which is there? Mediterranean Sea. Here which mountains are there? This is Mediterranean Sea. Here which mountains are there? Alp. We discussed which mountains are there. Alp mountain. Alp mountain lies over here. So again, the leeward side of Alp mountain, what will happen? You see which wind are blowing on the leeward side of one Alp mountain. It is referred as a fawn. Fawn is blowing where? Fawn is blowing on a leeward side of whom? Leeward side of Alp mountain. So again, fawn is a warm wind, warm and dry wind, which is blowing on the leeward side of Alp mountain. Fine. This is the reason when this warm and dry wind blows, it melts the snow. It melts the snow, and when it melts the snow, what you see is, especially in Switzerland, you see Switzerland is one of the important tourist destination. Why it is an important tourist destination? Because snow melts, colder condition drops, and that's why in winters also it is okay one of the tourism hotspot region. Clear? So Switzerland is famous because of what? Because of okay the colder condition get somewhat lesser when fawn blows, and fawn melts the snow, making it what? Making it possible for tourism and etc. Clear? So that is another thing you have to keep in mind with regard to what? With regard to fawn. Fine. Clear? So all these three type of winds are what? All these three type of wind, Chinook, fawn and Zonda are which type of wind? They are blowing on the leeward side of the mountain. One blowing in North America, one blowing in what? One blowing in South America, one blowing in Europe region, Alp region. That is okay there. Fine. Any doubt regarding this one?
Sir, does these local winds are also affected by season?
These local winds are also impacted by seasons. Yeah, somewhat seasonal effects are going to be there, but not much. Like we discussed, wind has to come. Which wind has to come? Onshore wind has to come. When this wind comes, then only what will happen? Which will form? The dry winds, warm dry wind on the leeward side will form. Sometimes due to shifting of pressure belt, what will happen? Wind flow, wind direction will change, and as a result, this wind may not form. Clear? They will form only in what? They will form only in these areas. That's why they are referred as a Chinook, fawn and Zonda. Local names are being given. Fine. Next we have written is Lu. Lu is where Lu you find in India. So where Lu is blowing in India. Fine. So basically Lu is a warm dry wind. It is warm or very hot dry wind. Hot dry wind are there, and this hot dry wind is blowing on the northern part of India. Northern part of India. This is generally coming from Rajasthan deserted region. So it is blowing over which part of India? Northern part of India, and this generally blows in the month of March, April. March, April, May, before arrival of monsoon. Okay, so late March to early May, before arrival of monsoon, you'll see this wind is something that is blowing. This is warm, hot, and dry wind. Fine. Now the Lu is considered as what? Lu is considered as a harmful wind. It is considered as which type of wind? It is considered as a harmful wind. Why it is considered as a harmful wind?
So because there is summer season and plus this increase the
Yeah.
summer effect.
Yeah. So what you see is, okay, since it is which type of wind, we have written dry wind. Dry wind means what? It does not have a moisture. When it does not have a moisture, what will happen? Evaporation rate will increase. Evaporation rate will increase. Moisture, okay, the air will absorb more amount of moisture. Clear? So what you see is already there is a hot condition. Hot condition means what? Moisture, evaporation will be more. And now the wind is also dry wind, and which will absorb more amount of moisture. So suddenly you will see plant will start losing, soil will start losing moisture, plant will start losing moisture. You'll see humans also will lose a lot of moisture. That is okay there. That's why you have heard about the term called heat stroke. A person dies with regard to what? With regard to heat stroke. So what is heat stroke? When your body temperature increases, and that is okay, what? That is a heat stroke. Clear? So what happens is what? This is Lu causes the heat stroke. Lu causes the heat stroke in human. Plants, they start losing water. As a result, plant dies off. Plant dies off. Soil will lose moisture. Soil will become very dry. Soil will become very dry. So it is not good for whom? It is not good for plant. It is not good for humans. And that's why this is considered as which type of wind? Harmful wind. Clear? So Lu is a local wind which blows when? In the northern part of India as we discussed, late March to early May. It is blowing in that particular period when monsoon wind is not there in India. So then this blows. When monsoon comes, monsoon brings relief, like cooling effect, rainfall is being brought, so monsoon brings a relief. Clear? So that is what, okay, you have to keep in mind with regard to Lu. Fine. Next wind that you are finding is what? Next wind that you are finding is a Sirocco and Harmattan. Sirocco and Harmattan, even Khamsin, they are all originating in the desert regions. Sirocco, Harmattan, and the Khamsin all are originating in which region? All are originating in desert region. So let's say this region. This is which region? Africa. You will find which sea is there? Which sea is here? Mediterranean Sea. Which desert is over here? Sahara Desert. Okay, so which desert is over here? Sahara Desert. Fine. Now, which country is over here? Any idea? So you'll find Spain, you'll find France. Those countries are something that are over here. Fine. So at the top of Mediterranean Sea, you'll find Spain, France. Those are the countries lying over here. Fine. Now, what happens is from here, from this desert region, a wind starts to blow like this. A wind starts to blow from the desert region, and when this wind is blowing in a desert means what will happen? It is going to be which type of wind? Dry wind, because evaporation is not going to be there in desert region. So this wind is going to be what? Dry wind. And Sahara is which type of desert? Sahara is which type of desert? Hot desert. So hot conditions are something that are prevalent, because you know that Tropic of Cancer is passing through what? Tropic of Cancer is passing. This is a hot condition, hot desert region. So hot and dry wind are something that are blowing. When this hot and dry wind are blowing, it will also pick up lot of what? Lot of sands. You know that wind picks up the sand and moves the sand from one area to another area. So this wind will also pick up what? Pick up lot of sands. Now, this hot dry wind, when it is moving over Mediterranean Sea, what will happen? This hot dry wind, when it is moving over Mediterranean Sea, what will happen? It will carry moisture. So moisture will also be there. Moisture will also be picked by whom? Picked by this wind. So now this wind is what? Hot and moist wind. When it is reaching to what? When it is reaching to Spain and France, it becomes okay, hot and moist wind which have sand. Hot and moist wind which have sand. Fine. So this wind is also carrying the sand, and it is now become hot and moist instead of dry wind. Why? Because it is blowing over which region? Mediterranean region. Fine. Any doubt regarding this particular thing? Now you know that this is which type of wind? Onshore wind. Onshore wind, any wind will move from where to where? From sea towards land. It becomes which type of wind? Onshore wind. And you know that onshore wind can create which type? They can create a rainfall. Onshore wind can create what? Rainfall, because they have the moisture. So they have the moisture, so they can create what? Rainfall. So this hot moist wind create rainfall where? They create rainfall in Spain and France region. This create rainfall where? In Spain and France region. There you see rainfall is something that is okay happening. Clear? So when rainfall will happen, what will happen? What will happen? Along with the rain, what will come down? Along with rain, what will come down? The sand particles will also come down, because the air was containing what? Air was containing sand, and when rainfall will happen, the sand particles will also come down. Clear? You know that sand particles are which type of particle? Bigger particles, smaller particles? No. Sand particles are which type of particle? Bigger particle. We have discussed arenaceous and argillaceous. Remember, argillaceous are which type? Small particle. What is example of argillaceous? Clay stone. Yes. So clay particles are smaller. We discussed sandstone particles are what? Bigger. Sand is a bigger particle. So when bigger particle is there, will it absorb more moisture, or will it not absorb moisture? Sand is going to absorb more moisture, or it will not absorb moisture? It will not absorb, because we discussed bigger particle means water will penetrate what? Water will penetrate downward. Clear? Smaller particles means what? Smaller particle, they will not allow the water to go downward. That's why we discuss argillaceous rock do not have a groundwater. Arenaceous rocks do have what? Groundwater, because water percolate inside. Rather than soil holding the moisture, what will happen? Water will go down. Clear? So as a result, you see when sand particles comes down, what will happen? It makes a soil a bit infertile in nature. It makes soil a bit infertile in nature. Why it becomes infertile? Because it is not holding moisture. Moisture is going down. Clear? So it is making soil a bit infertile in nature. That is okay there. Clear? Secondly, when this when this sand particles comes down, a lot amount of sand particles comes down, the color of the rain is sometimes sometimes becomes red. That's why it is called as what? It is also referred as a bloody rain. It is also referred as which type of rain? Bloody rain, because the red sand particles are something that are coming down. So that's why it is referred as which type of rain? It is referred as a bloody rain also. Fine. So that's why when this type of wind goes from here to here, it creates a rainfall where? In Spain and France, making it difficult to what? Making it difficult for agriculture. And because of the color, it is referred as what? It is referred as a bloody rain. It is referred as which type of rain? Bloody rain. So this wind that is blowing from here to here is referred as what? This wind that is blowing from here to here is referred as a sirocco. What it is referred as? It is referred as a sirocco. So the sirocco wind is also referred as a which type of wind? Bloody wind. Okay, it is also referred as which type of wind? Bloody wind, as this causes nothing but the rain. Fine. Fine. Now from the same Sahara Desert, one of the wind also comes toward this side. One of the wind also comes toward this side, like this. Okay, wind will come towards this particular side. Again, which type of wind it is going to be there? Hot and dry. This is going to be which type of wind? Hot and dry wind. Why? Because originating in desert region, hot desert, so it is going to be which type of wind? Hot and dry wind. Now, this is which area? This is coastal areas. This is which area? Coastal areas. Just now we discussed coastal areas. What during daytime, what the people will feel? They will feel uneasy. Why uneasy? Because we discussed the winds which are coming from the here carries lot of moisture, that is carries lot of moisture, and it retards the evaporation in this region. But when dry wind will come, what will happen? When dry wind will come, what will happen? It will increase the rate of evaporation. So when dry wind is coming from Sahara region, what will happen? It will increase the rate of evaporation. That's why people will feel relief. Okay, because earlier, because of the sea breeze, people were feeling what? People were feeling uneasy. But when dry winds are coming, suddenly you see increase in evaporation. When increase in evaporation, what will happen? People will feel relief. So such winds are referred as a harmattan. Such wind is referred as a harmattan, and that's why since it brings relief to the people, it is also referred as a doctor's wind. Locally, it is called as which type of wind? Locally, it is called as a doctor's wind, as it brings relief to the people. Locally, it is referred as which type of wind? Doctor's wind. Fine. Fine.
So sandstone or porous in nature.
Sandstone or porous in nature, yes.
So porous means they can absorb water.
Porous means water will go down. They will not hold.
Okay.
Porous means it will percolate at the downward part. They will not hold the water. Clear? When any soil holds the water, then what will happen?
Absorbing capacity.
Then plant can absorb it. Clear? But if the soil allows the water to go down, then what will happen? Then at the upper level, okay, you don't have a water. Water has gone groundwater. At upper level, you don't have a water. So the roots will not be able to absorb water. Clear? So as a result, okay, plants will not be growing much in this region. Clear? That's why when we'll come to what? When we'll come to climatic condition, we'll find in desert region, you'll see what? You'll see the roots are much deeper in nature. Why they are much deeper in nature? To take the groundwater. Clear? They are much deeper in nature. In the normal case, when rainfall is happening, roots are not going to go much deeper. Clear?
So when the sand particles come with the rain, it gets mixed with the soil.
It gets mixed with the soil.
Allowing the water to go to the ground.
Yeah, the upper layer is now what? Upper layer is now consisting of sands. Okay, it is consisting of sand. Sand layer has been formed. Now, what will happen? It will not hold moisture. When it will not hold moisture, root will not be able to what? Able to get the moisture because water has gone downward. Clear? So as a result, okay, what will happen? You'll see agriculture becomes difficult, and that's why it is not considered good rain. That's why they also called it as which type of rain? Bloody rain. Fine. And this is okay, bringing relief to the people. That's why it is beneficial and called as what? Doctor's wind. Fine. Now here to here, again one wind will blow from this direction. Wind will blow in this direction like this. Clear? From Sahara Desert, another wind will blow in this direction. This is called as a Khamsin. This is called as a which wind? Khamsin. So Khamsin blows. Which country lies over here? Which country? No. Which country lies in Africa? This part is which region? Ethiopia is this part. Egypt. At the top you will find which country? At the top you will find Egypt. So you'll find Egypt, you'll find Red Sea, and you'll find Eastern Europe. Eastern Europe. So Khamsin is blowing over what? Khamsin is blowing over Egypt, it is blowing over Red Sea, and it is blowing over Eastern Europe. Eastern Europe. Again, it is a which type of wind? Hot and dry wind. It is originating from where? It is originating from the desert region, Sahara Desert region. So it is again which type of wind? Hot and dry wind. Okay, that is okay there. Clear? Any doubt regarding this one? Not beneficial. Not beneficial. Clear? Causes lot of evaporation. Hot and dry wind causes lot of evaporation. Fine. So these are okay. What? These are your another type of wind that you are finding. So this is okay. What? This is your Khamsin, Harmattan, and Sirocco. Sirocco we discuss is which type of wind? It is called as a bloody rain. It causes bloody rain. Harmattan is doctor's wind. Khamsin blowing over Egypt and other region. All originate where? In the African region. All originate in the African region. Fine. Last is your sand tenor. Santa Ana is a wind that you find in California region. It is okay, blowing in a California region. So you'll find this is how, okay, North America is there, and you'll find like this. So this part is referred as which region? California region. So this part is okay, referred as which region? California region. Now this wind is blowing towards something but okay, easterly direction. It is blowing towards easterly direction like this. This wind is flowing. It is called as a Santa Ana wind. It is called as a Santa Ana wind. Fine. Blowing over California, Santa Ana. Again, this wind causes wildfire. Wildfire. Recently you saw a huge wildfire where? In the US. In the US, okay, you saw a huge wildfire this year. This is mainly caused due to which wind? Santa Ana. Because Santa Ana is which type of wind? Hot and dry wind. Hot and dry wind. So what will happen? It absorbs all the moisture, making things more drier. Plant becomes drier, forest becomes drier. And even a spark of, okay, what? Even a spark can cause now wildfire. Clear? And since wind is blowing also, what will happen? Spread the fires. Clear? So that's why the Santa Ana wind is okay, responsible for what? Santa Ana wind is responsible for wildfires. Clear? Any doubt? So not a beneficial wind.
Is this an offshore?
It is offshore, yes. Okay, offshore wind, drier wind. What you see is causing what? Causing the wildfire. Fine. So if you see the news, so you can see this year, you can see this Los Angeles wildfire. You can see in January, dryness keeps risk new fire high. Clear? So you can see it was a much bigger fire. It was a much bigger fire this year caused due to the wind. And you can see there is a wind also, as we discussed. You'll find so see here what is mentioned, how Santa Ana wind made Los Angeles wildfire so dangerous. Okay, so this is what explanation is something that is okay given. So as we discussed, Santa Ana wind is which type of wind? It is hot and dry wind. Causes what? Causes lot of evaporation. When lot of evaporation will happen, what will happen? Things become drier. So even a spark can cause what? Fire over there, because things are dry. And since wind are blowing, what will happen? Is fire will much spread, and as a result, okay, you see lot of okay big fire has happened in the case of Los Angeles region. So that is why Santa Ana is also in use. Okay, you can see Southern California region. Los Angeles is lying in Southern California, so it lies in the Southern California is a state, Los Angeles is a city part of that particular region. So what you see is the role of Santa Ana wind. You can see the strong dry wind originate in the Great Basin, a desert spanning Nevada and Utah. So we discussed flowing towards where? Flowing towards the eastern direction, and then spreading this particular fire that is okay there. Clear? So these are Santa Ana wind. Clear? So this is in news. Question might come that Santa Ana is related to what? Santa Ana is blowing where? Clear? So you have to keep in mind this is blowing in which region? California region. It is originating easterly direction. Originating from where? Originating from the deserted region of okay, the America. Leeward side, we discussed leeward side is going to be which region? Rocky Mountain. Leeward side is going to be deserted region. So from those deserted region, winds are originating and blowing in the easterly directions. Fine. So where you see Chinook, North America. Where you see Santa Ana, also in North America, that is in California. Where you see the fawn, where you see fawn in the Alp region, Europe region. Where you see Jonda, South America, Andes mountain, leeward side of Andes mountain. Then we have discussed which one? Sirocco. Sirocco is which one? Where do you see Sirocco? Yeah, it is in case of Spain and France, moving from Sahara region. Then the Harmattan moving towards coastal areas of Africa, and it is okay referred as which type of wind? Doctor's wind. Khamsin
Red Sea,
moving towards Red Sea, Egypt region, that is okay there. And we discussed Lu. Lu is where?
India.
India. Fine. So these are warm local wind that you have to keep in mind. Clear? Have a break and then we'll start with cool local wind. Ma'am, it's there with ma'am. Okay, both are corrected. Okay, you can take it. Test 2, test 3, both paper are there. Huh? Test 3 we'll discuss tomorrow. Okay, so we'll discuss tomorrow. Test 3, prelims and means. Fine. So now we are coming to what? We are coming to the cold local wind. We are done with the warm local wind. So now we are coming to the cold local wind. Cold local winds are Bora, Mistral, Pampa, Blizzard, and Grigel. These 5 are together called as a cold local wind. Fine. Now these 3, Bora, Mistral, and Grigel, they are more in European region. They are in European region. So you'll find Bora, Mistral, and Grigel. They are more in European region. European region means in the near in and around Alp and Mediterranean region. Alp and Mediterranean region. So if you look at Mediterranean Sea, this is how you'll see. So this is how you'll find. Okay, if you're looking at a Mediterranean Sea, this is how you'll find things over there. Or I'll just show you map itself. So fine, this is the map you are finding with regard to Mediterranean Sea, and what you'll see here is what here you'll see is Adriatic Sea. So this part, if you see, this part is referred as Adriatic Sea. The Italy upper side, Italy lower side is referred as Tarian Sea. Okay, Italy lower side is referred as the Tarian Sea. This is a Greece. This is a Greece, and you will find Aegean Sea. Clear? So in Mediterranean Sea, you are seeing 2 countries that are extending. One is Greece, another is Italy. So on the other side of Italy, you are seeing Adriatic Sea. Here you are seeing which type of sea? Here you are seeing Aegean Sea. Clear? And this entire region is okay. What? This entire region is referred as a Mediterranean Sea. So this entire region is referred as what? Mediterranean Sea. Fine. Now this region, as we discussed, is which region? Alp region. So we discussed this is where your Alp mountains lies. So this is a Alp region. Now the wind that blows from Alp towards France, wind that blows from Alp towards the France, colder wind. This is cold and dry wind. So this is cold and dry wind because it is originating from the mountain region. It is a dry wind, cold wind. The wind that is blowing towards France is referred as a Mistral. This colder wind is something that is referred as a Mistral. And the wind that blows like this towards Adriatic region is called as a Bora. So Bora is more towards eastern side, while Mistral is more towards western side. Clear? So you are finding Bora as well as Mistral. Mistral is more towards western side. Bora is more towards what? side. Bora is coming down towards Adriatic region, while this is okay, moving towards what? This is moving towards France region. Fine. And there is another sea which is called as a Grigale. Now there is another, in another wind which is called as a Grigale. Grigale is in the center of Mediterranean Sea and western part of Mediterranean Sea. It is blowing in the western part of Mediterranean and central part of Mediterranean Sea. So you can see the small island. This small island you can see. This is Malta. This small island is a Malta island. While this is okay. What? This is a Sicily. Sicily is a part of Italy only. This Sicily is a part of Italy only. This part is okay. What? This part is referred as a Malta region. Clear? So Grigale is the colder wind that blows like this towards western part. That is okay. These part you are seeing Sardinia, Corsica, Sicily, which are all part of Italy only. These are all part of Italy only, but Malta is an independent country. So the one which blows over Malta, the one which blows over the island that lies in the Mediterranean Sea is called as a Grigale. Fine. So three things are there. One is Bora, another is called as a Mistral, and the third thing is called as a Grigale. All are your what? All are your cold wind and drier wind. Drier wind. Grigale sometimes pick up what? Grigale sometimes pick up moisture. Why? Because it is blowing over which region? Mediterranean region. Clear? So Grigale sometimes pick up moisture, and this causes snowfall. This causes snowfall in Malta during winter season. Clear? So this causes snowfall when it pick up moisture. This moisture condenses further and forms a snowfall in the Malta region. Fine. So these are the three colder winds. Which wind?
What are causes this snowfall?
Snowfall when Grigale blows over what? When Grigale blows over the Mediterranean region, pick up moisture. When moisture is there, this moisture will condense and it will cause what? Ice to form or snowfall to form. So that is what happening in the Malta region. Fine. So remember three direction. From Alp region, one wind is originating, moving towards France. This wind is called as what? This wind is called as a Mistral. One wind, this is moving towards what? Towards Adriatic region. This is called as a Bora, and one that moves over the Mediterranean region is called as a Grigale. Fine. Grigale. So these are okay. What? These are the three major winds that you are finding. And two other that you have is a blizzard and Pampero. So Pampero is blowing where? Pampero is blowing in Argentina. Where Pampero is blowing? In Argentina, in the Southern America. So here you'll find this is what Andes are there. This is where we discuss Argentina, and this part we have written as a Paraguay. If you remember, Paraguay also we have discussed that Andes do not passes through Paraguay, if you remember. Clear? This region is referred as a Rio de Plata. Rio de Plata. Clear? So Pampero blows more over this region. It is a colder wind. When there is a cold condition in the southern hemisphere, when there is a cold condition in southern hemisphere, when there is a cold condition, winter solstice is with regard to northern hemisphere. Colder condition is going to be what?
Summer solstice.
Yeah, summer solstice. When northern hemisphere is facing summer, then southern hemisphere will face what? Winter condition. So generally this Pampero blows when? Between June to September. So this generally blows between what? June to September. It generally is blowing in this month. Clear? And it is a colder, drier wind. Colder, drier wind that you find. And the last is your, okay, what? The last is your blizzard. So blizzard is described as a very violent, gusty wind. Violent, gusty, cold wind. Cold wind. It is described as a violent, gusty, cold wind, where blizzard is flowing over here in Canada, in Siberian region, that is upper part of Russia, in Siberian region.
What about Himalaya?
Himalaya, so we don't have that much cold wind. Himalaya is blocking the cold wind. Okay, so this wind which is blowing this is blocked by the Himalayas. So that's why our temperature doesn't drop as much as compared to European region, though latitude is same, but Himalaya is blocking the colder wind. So that's why you don't see much of colder wind in this condition. We have a cold wave conditions, but as such no cold local wind. Fine. So this part that you see is a Siberian region, and the Siberian region is where you see blizzard, that is violent gusty cold wind are blowing. Fine. This causes lot of snowfall. This causes lot of snowfall here in Canada, here in case of Siberian region of Russia. Fine. So these are the five cold local winds. So what are the winds we have discussed? Grigale, Pampero, Bora, Mistral, and Blizzard. Fine. So these five together are referred as what? These five together are referred as cold local wind. Fine. So in examination, you may get a question like this. Which is correct?
So first is correct.
First is correct. Okay.
So
First is correct.
Chinook is on Andes or Chinook is on Rockies?
Rockies.
On Andes, what is there?
so
Zonda. So first is wrong statement. Warm dry wind on the leeward side of what? Rockies, not Andes. So first is wrong. Second, blizzard, cold gusty wind in the Antarctica region. We discussed it is blowing where?
in Canada,
Canada, that is Arctic region. So above Canada, above Siberian region, what you are finding? Arctic region. So it is not Antarctica region. Wrong statement. Sirocco, warm dry wind towards coast of Africa. Is it correct? Where Sirocco is blowing? Towards France and Spain. We discussed there it is called as what? There it is called as a bloody rain, bloody wind. Clear? Causing bloody rain. Fine. So which is moving towards coast of Africa? Harmattan. Yes. Okay. So Harmattan is moving towards coast of Africa. It is moving towards what? It is moving towards European region. Sirocco is moving towards European region. So none of the pair is what? Correctly matched. Like this, okay, you'll get a question in the case of examinations. Fine. Any doubt regarding this one? So this finishes your what? This finishes your classification of winds. So we discussed winds are permanent wind. What are the permanent wind? Trade northeast trade wind, southeast trade wind, westerlies and easterlies. Then we discuss secondly is secondary wind. Secondary wind are classified into seasonal wind and periodic winds. What are the seasonal wind? Southwest and northwest monsoonal wind. What are periodic wind? Mountain and valley breeze and land and sea breeze. Which wind is called as a katabatic wind? Which wind is called as a katabatic wind? The wind that is okay, what, descending, the wind that is descending coming from mountain towards valley is called as what? Katabatic. The wind that is okay moving from the valley towards okay mountain is referred as what? Anabatic wind. Fine. Then we discussed onshore wind. Which wind is referred as an onshore wind? Wind which carries moisture and creates rainfall from and moves from sea towards land. Those winds are called as a onshore, and other is called as a offshore. Fine. Then we discussed a warm local wind, and cold local wind. So remember which area these winds are blowing. That could be asked in case of examinations. Fine. Next concept you have is a air mass. Air mass. What is air mass means? As the name indicate, air and mass. Mass means huge in number. So when air blows over an area for a long period of time, when air is moving towards an area for a long period of time, it acquires the characteristic of that area. It acquires the characteristic of that area. Clear? What is air mass? When huge mass of air blows over an area, when huge mass of air blows over an area for a long period of time, it acquires the characteristic of area, and that's why it becomes homogeneous in nature. It becomes homogeneous in nature. Homogeneous means what? Similar type of character, similar type of things. Homogeneous, heterogeneous. Heterogeneous means different thing you are mixing. Homogeneous means what? Similar thing. Clear? So when it acquires the characteristic of area, all air will have similar characteristic. When it becomes similar characteristic, then it is going to be called as what? Air mass. Clear? So air mass is, let's say this is the area. You can see air may blow over here, air may blow over here, air may blow over here. Clear? So what you see is when entire air acquires the characteristic of this area, then it is going to be called as what? Then it is going to be called as a air mass. Fine. For example, we say that when the air will move onto the land, it is going to be which type? It is going to be which type of air? Dry air. Why dry air? Because moving over what? Land. When it moves over oceans, what will happen? It acquires the moisture. So that air will have moisture. Why? Because it is moving over. So it is acquiring the characteristic of that particular area. So when air acquires a characteristic of a particular area and becomes homogeneous, then it is called as what? Then it is called as a air mass. Clear? So what you have to keep in mind is when air blows through over an area for a long period of time, it acquires what? It acquires the characteristic of that area and becomes homogeneous in character. And that is called as what? That is called as a air mass. Fine, any doubt? Now air mass is broadly classified into based on their source of origin. Either the source of origin, where they are originating, or based on temperature also you can classify. Clear? Based on temperature you can classify, or based on source of origin. This is much acceptable classification, source of origin, because we are going to study in terms of source of origin. But based on characteristic temperature also you can classify the air masses. Clear? So whether the air mass is originating in tropic region or whether air mass is originating in polar region. In the tropic region, they can originate either on the continent or on the oceans. So that's why the air mass is referred as continental tropics, or it can be referred as in the polar region also. They can originate either on the continent or on the oceans. So here it is referred as a maritime. Here it is referred as continental polar, maritime polar. So based on based on source of origin, you see the air masses are classified like this. So they can originate either in tropics region or they can originate either in polar region. In tropics region, if they are originating, you can classify them as a continental tropic or maritime tropic. In polar region, if they are originating, you can classify them as what? Okay, continental polar or maritime polar. Or based on temperature also you can classify based on cold air mass and warm air mass. Cold air mass, warm air mass, you can also classify based on that. Fine. So what is air mass? Air mass is homogeneous air. When air become homogeneous, when it blows over, okay, an area for a long period of time and acquires the characteristic of that area, that air is going to be called as what? Air mass. Air mass can be classified based on their source of origin, or they can classify it based on temperature. Based on temperature, it can be warm air mass or cold air mass. Based on based on this, you can have either source of origin, you can have either tropic origin or polar origin. In the tropics, they might either originate on the continent, so continental tropic, ocean, maritime tropics, continent if they are originating, continental polar, oceans if they are originating, maritime polar. Fine. What is the difference that you are finding in this one? So first is continental tropic, and second you find is what? The maritime tropic. So you know that which region receives more sunlight? You find this is a tropic region. Tropic, you will have land mass, land also, you'll have ocean also. Fine. So tropic region, you know, receives what? Receives more amount of sunlight as compared to which region? Polar region. Clear? As compared to polar region, tropics region receives more amount of sunlight. So that's why both of these winds are going to be what? Hot wind, because they are originating in what? They are originating in the tropic region. Tropic receives more amount of sunlight. So when they receive more amount of sunlight, both wind are going to be which type of wind? Hot wind only. That is okay there. Clear? But since it is originating on the continent, it is going to be which type of wind? It is going to be which type of wind? Moist wind, because it is originating over ocean, and you know that blowing over the ocean, they will pick up what? They will pick up the moisture. So it is going to be which type of wind? Moist wind. Fine. Now this hot and dry wind, which is originating is called as a which type of wind? Offshore wind. Offshore wind. This moist, humid wind is going to be which type of wind? Onshore wind. Onshore wind. So this is offshore wind, while this is nothing but onshore wind. Fine. Now another important thing is this type of wind, hot wind, is going to what? Going to evaporation will be high. Evaporation will be high in this region because it is a dry wind. Evaporation will be high, and this evaporation here will be low. In this type of wind, evaporation will be low because it is a moist wind. Evaporation will be a bit low as it is a moist wind. So here you'll see high evaporation. Here you'll see nothing but what? Lesser evaporation. Fine. Fine. Now this type of wind will create a stable weather condition. Stable weather conditions. While this type of wind brings rainfall, so create which type of condition? Unstable weather conditions. So it is going to create unstable weather conditions. Fine. Maritime tropic is going to create which type of condition? Unstable weather condition. It will change the weather, brings rainfall, sometimes cloudy weather, other weather. Continental tropic will more create a stable weather conditions. Fine. So this is how you find the characteristic of air mass. Similarly, you have which type of air masses? You also have continental polar and maritime polar. You also have continental polar and you also have maritime polar. So continental polar is which type of wind? Cold wind. Originating in polar region means it is going to be which type of wind? It is going to be cold wind. Fine. Fine. Again, continent means what? Which type of wind it is going to be there? Dry. So it is cold and dry wind. It can be cold and humid wind or cold and moist wind. It is a cold and moist wind. Fine. So it is a moist wind. It is a dry wind. Fine. Continental polar is going to be offshore, but mostly offshore. Mostly offshore. This is going to be mostly onshore. Mostly onshore. Fine. Why we are writing mostly offshore? Because sometimes you see snowfall can happen because it is a cold wind. Excessive cold can cause nothing but okay snowfall. Why snowfall can happen? Because on the land also you'll see sometimes okay rivers are there, other things are there. So they will give certain moisture, and when they will give certain moisture, what will happen? You'll see some snowfall may happen. So mostly offshore is there. It is mostly onshore, and what you see is okay. Both are okay. What? Both are colder wind. So that's why evaporation rate is going to be what? Lower. In both cases, evaporation rate is going to be lower. It is going to be lower evaporation rate. Fine. It is much lower in case of maritime. It is slightly lower in case of nothing but okay continental polar, because it is having no moisture. It is having more moisture. So here evaporation rate is further lower. Here evaporation rate is lesser. Clear? Now it will create a stable weather condition, while it is going to create which type of condition? Unstable weather condition. Unstable weather conditions. Fine. So this is what the characteristic that you have to keep in mind with regard to continental polar, maritime polar. Fine. So this is all about concept of what? Concept of air masses. Fine. So what is air mass? How do we define the term air mass? When air acquires the characteristic of that area and becomes homogeneous in nature, then such air is called as what? Air mass. Air mass can be classified based on what? Cold air mass and warm air mass. If cold air mass and warm air mass, what you are going to write? These are warm air mass. Continental, tropic and maritime tropics are going to be what? Warm air mass. These are going to be what? Continental polar and maritime polar is going to be which type of air mass? Cold air mass. Fine. So you can classify also as a cold air mass or warm air mass, or you can classify based on their source of origin. So whether origin is tropics region or whether origin is nothing but okay polar region. Fine. Next is your concept of temperature inversion. Next concept comes to temperature inversion. Fine. So what is temperature inversion? Earlier we have discussed this concept of temperature inversion. What is temperature inversion? What is temperature inversion? We discuss as we go up in troposphere, what will happen? Temperature declines. As we go up in troposphere, temperature declines, and this is called as what? This is called as what? As you go up, temperature declines, and this is called as what? This is called as a lapse rate. Already we have discussed normal lapse rate, dry adiabatic lapse rate, okay, wet adiabatic lapse rate. As you go up, temperature declines, okay, and this temperature declines is called as what? Lapse rate. We discussed normal lapse rate, okay. This is referred as which type of lapse rate? Normal lapse rate. When rising air are there, then what will happen? Adiabatic lapse rate. Non-rising air are there, then what will happen? Normal lapse rate. Fine. So that we have discussed. So as you go up, temperature decline, and this is referred as what? This is referred as a lapse rate. Now as you go up in troposphere, if temperature start increasing, then this situation is called as what? This situation is called as a temperature inversion. So as you go up and temperature start increasing, this is going to be called as what? This is going to be called as a temperature inversion. Fine. Fine. Clear? So when this phenomena of temperature inversion will occur, when you go up, temperature will start increasing. When this phenomena will occur, for this certain condition has to be fulfilled. For certain condition has to be fulfilled, then only temperature inversion phenomena can occur. What are the conditions? The first condition is there should be long night. Long night means duration of night should be greater than what? The daytime. Duration of night should be greater than the duration of day. Long night. Second, preferably which type of long night? Winter. Which type of long night? Winter conditions. Clear? You know that in winter what is happening? Daytime is shorter, night time is what? Longer. So you need a long night. Night should be greater than what? Night should be greater than day. And the second thing is what? Second thing that you require is winter conditions. Fine. The third thing that you require is what? The third thing that you require is calm air. Calm air. Clear? The third thing that you require is calm air, or you can also write stable weather. Stable weather. Calm air or stable weather. Fine. That is okay. Another important condition. And the fourth thing, okay, that you see is what? No cloudy weather. No cloudy weather. It requires a stable weather. No cloudy weather need to be there. Fine. These conditions need to be fulfilled. Then it is going to be called as what? Then it is going to be called as a concept of temperature inversion. If these conditions are not there, then it will not be called as what? It will not be called as a temperature inversion. Fine. So what happens in temperature inversion? As you go up, instead of temperature declining, if temperature start increasing, then it is going to be called as what? Temperature inversion. Normally what happens? As you go up, temperature decreases, and this is referred as what? This is referred as a lapse rate. But when opposite happens, as you start going up, temperature start increasing, this phenomena is called as what? This phenomena is called as a temperature inversion. Fine. Now, why you require long night or winter conditions? Why this is something that is very important? This is very important because you know that during the daytime what happens? Earth receives what? Earth receives sunlight. Earth receives sunlight, so Earths get heated. Earths get heated during daytime. And during the night time what happens? Earth starts to radiate this light. Earth radiate this light. Radiate this heat, which is okay there. Earth radiate this heat, and Earth cools down. Fine. Fine. So during the daytime, what is happening? Earth is receiving the heat, and that's why Earth is getting heated. And during the night time, what is happening? Earth is cooling down because it is radiating heat. Fine. Now, if Earth cools down, and Earth sufficiently cools down, if long night are there means what? Long night are there means what? That during the daytime you are not receiving much heat, during the night time you are radiating much heat, and as a result what will happen? You will become cool down. When you become cool down, what will happen? At the surface you have a colder temperature because Earth is cooling down, so at the surface you will have colder temperature, or air that comes in contact with the surface becomes what? Cold. But air that is not in contact with the surface will remain what? Will remain warm, because it is not in contact with the Earth's surface. The air which is in contact with the Earth's surface becomes cold. Why? Because the Earth is becoming cold, so air is becoming cold. But air which is not in contact with the Earth will not become cold. It will remain warm. So as you go up, what will happen? Temperature will increase. As you go up, temperature increase from cold to warm. This will only occur when you have either long night or you have sufficiently winter condition that is okay there. Clear? So then only you see Earth will cools down more. When Earth will cools down more, what will happen? Temperature at Earth's surface will be decreases. When temperature at the Earth's surface decreases, what will happen to air? Air will nothing but okay also decrease. Air temperature will also decrease. Air temperature decreases means what? You'll see temperature inversion phenomena. So that's why this is very important. Second thing, we have written stable weather or no cloudy condition. If cloudy conditions are there, then what will happen? If cloudy conditions are there, then what will happen? Yeah, it will reflect whatever heat that earth is radiating. This heat will be again reflected back where? Again reflected back onto the earth surface. You know that cloud absorbs heat, no? Heat budget we have discussed. What heat budget we have discussed? When sunlight comes, what will happen? Some amount is reflected by atmosphere, okay, some is reflected by the clouds, and some is reflected by earth's albedo. And we discussed how much is reaching to the earth's surface. Only around 51 unit is reaching to the earth's surface, and this is again radiated by no? Radiated by the earth's surface. So we have discussed incoming radiation and we have discussed the outgoing radiation. So what will happen? Cloud is what? Cloud is reflecting things. Cloud is reflecting thing, that is okay there. Clear? So when cloud is there, whatever heat earth is reflecting, it will again reflect it back to the earth's surface. So earth will not cool down because earth is again getting heat. Whatever heat earth is reflecting, that heat is coming back to the earth's surface. So the earth will not cool down. So that's why you require which type of weather? No cloudy weather. If clouds are not going to be there, then whatever heat earth is reflecting, it will go away in the space. Okay, that is okay there. Fine. So this is a reason why you require stable weather and no cloudy weather, that is okay there. When clouds are going to be there, rainfall is going to be there. So rainfall means what? Rainfall means unstable conditions are there. So you require a stable weather condition, no cloudy weather, where easily light or heat can escape. Fine. So that condition is something that is okay, very important for cooling purposes. Fine. The third that you require is calm air. Why calm air? Why calm air you require? What is the reason why you require calm air? If air is moving, then what will happen? It is not a calm air. Calm air means what? That air is not moving, air is static. That is okay, what we call as a calm air. Clear? When air is moving, then what will happen? It is not going to be a calm condition. Windy conditions is going to be there. Clear? So when air is moving, we discuss horizontal motion of air is called as what? Wind. So when wind is moving, what will happen? It is going to be called as a windy conditions. Fine. When it is okay, what? When air is not much moving, wind is not much moving, then it is going to be called as what? Calm air condition. That is okay there. Why calm air condition is required? Why this condition is something that is okay required? Because if air is moving, then what will happen? Air will not be in contact with whom? Air will not be in contact with the earth's surface. When the air will cool down, when the cold air temperature will be dropping, when it will be in contact with what? Earth's surface. When air is moving, then what will happen? It will not be in much contact with the earth's surface. When it will not be in much contact with the earth's surface, what will happen? Cooling will not happen. When cooling will not happen, then what will happen? You don't see the temperature inversion phenomena. Clear? So for temperature inversion phenomena to occur, air should not much move. If air is much moving, then what will happen? You don't see temperature inversion phenomena. Air need to be static for a long period. Then only what will happen? Air will be in contact with the earth's surface and air will sufficiently cool down. Clear? So these condition has to be met. Then only what will happen? Temperature inversion phenomena is going to be occurring. Fine. Any doubt regarding this one? So what is a temperature inversion phenomena? When as you go up, if temperature start increasing instead of decreasing, it is going to be called as what? Temperature inversion phenomena. And it occurs when? It occurs during the long night. It occurs during what? Winter night. Winter conditions need to be there. Calm air need to be there, and no cloudy weather condition need to be there. Fine. Any doubt regarding this one? Now that's why if you have experience, okay, what if you experience some colder condition, if you have gone to northern part in winters, northern India in winters, whenever you see wind is blowing, that time you don't experience fog and etc. During the daytime, whenever wind is flowing, cold wind are flowing, you don't experience fog. When you don't see, okay, what, wind blowing, that time you experience what? You experience fog. Why you experience fog? Because air is in contact with what? Air is in contact with the earth's surface. When air sufficiently cools down, what will happen? The vapor or moisture in the air will what? Condense and form what? Condense and form a fog. Okay, they will condense and form a fog. Fine. So when air which is in contact with the earth's surface contain moisture, this moisture condenses and forms, okay, what? droplet, that is called as nothing but okay, foggy conditions. Clear? So when wind is blowing, what will happen? Air will not cool down. When air will not cool down, fog will not form. Clear? So that's why to fog to form, air also need to be what? Air also need to be nothing but okay, static, not much moving. Clear? Any doubt regarding this particular part? So this is what we called as a temperature inversion phenomena. Fine? Any doubt? Now there are three types of temperature inversion. Broadly, we have a three different type of temperature inversion. They are called as a air drainage type of inversion, air drainage type of inversion, or they are called as ground or surface type of inversion. And the third type is a frontal type of inversion. So three different type of temperature inversion that you are finding. Air drainage type of temperature inversion, ground surface type of temperature inversion, and frontal type of temperature inversion. These three classification you are finding with regard to what? Temperature inversion. Fine. When do you see air drainage type of temperature inversion? When do you see air drainage type of temperature inversion? This generally is found in a mountain areas. Which type of area you'll find? This is generally found in which type of area? Mountain areas. So what happens in a mountain areas? Just now we discussed mountain breeze and valley breeze. So let's say this is a valley region, this is a valley region, this is a mountain region. This is mountain region, this is a valley region. What happens in night? What happens night? We discuss mountain starts to lose heat faster than what? Mountain slope, we discuss, starts to lose heat faster than what? Faster than the valleys. Clear? It is starting to lose heat faster than what? Valleys. And valleys, okay, at the valleys what will be formed? Low pressure is going to be formed. And where it is okay going to be formed? High pressure is going to be formed over here because it is cooling down. When we discuss colder condition, which pressure is going to be formed? High pressure. Warmer condition, which pressure is going to be formed? Lower pressure. So we discuss night time, which type of breeze is moving? It is called as which breeze? Valley breeze. The wind will move from high pressure to low pressure, so it is going to be called as which breeze? Mountain breeze. Fine. It is going to be mountain breeze. Now during the daytime, what happens? We discuss the valley, mountain slope will receive lot amount of sunlight. Lot amount of sunlight means what will happen? Here we discuss low pressure. Valley is not receiving much of sunlight, so what is happening? High pressure. So okay, you are seeing which type of thing? You are seeing which type of thing over here? Valley breeze. Valley breeze. Now low pressure means what? Low pressure means which type of condition here is there? Warmer condition, because low pressure is going to be formed when there is okay, which type of condition? Warmer condition. High pressure means which type of condition? Colder condition. High pressure means colder condition. So as you are moving from here to here, what is happening? As you are moving from this layer to this layer, what is happening? Temperature is increasing or decreasing? Increasing. Temperature is increasing. So it is which type of temperature inversion? Air drainage type of temperature inversion. Clear? So in the mountain region, you will see the valley is what? Valley is during the daytime. Valley have what? Valley have nothing but okay, colder condition, while mountain slope get heated. As a result, air in contact with the mountain slope become warmer, and air in contact with the valley becomes what? Colder. So as a result, you will see when you are moving from here to here, what is their air drainage type of temperature inversion. Fine. Fine. So this type of okay phenomena you are going to see in what? This type of phenomena you are going to see in temperature inversion. Any doubt? So remember that in the daytime, what will happen? In the daytime, you will see the valley cools cools more, valley is colder more, and that's why high pressure. And here you'll find which type of pressure? Low pressure. Valley breeze is going to be there from here to here. So air in contact with the mountain, becomes warmer. Air in contact with the valley becomes colder. So this is a colder condition, this is warmer condition. As you're moving from here to here, temperature will increase, and this type of inversion is called as what? Air drainage type of inversion. Clear? So where do you observe air drainage type of temperature inversion? In mountain region. In mountain region, you'll observe air drainage type of temperature inversion. Fine. The second type of temperature inversion is what? Ground or surface type of inversion. Ground or surface type of inversion. Now this type of inversion you generally see in a planar areas. In plain areas, you generally see ground or surface type of temperature inversion. So as we discussed, what happens during the daytime? The earths get heated, and during night time what will happen? It will start to lose heat, so it will cool down. It will cool down. So air in contact with the earth, air will in contact with the earth cools down, but air not in contact with the earth remain warms. As a result, what happens? As you are going up, temperature will increase. As you are going up, temperature will increase, and such type of inversion are called as what? Ground surface type of inversion. Fine. So this occurs where? This occurs in a planar areas. In planar areas, when the planar region will cool down or earth surface will cool down, air in contact with the earth surface becomes colder, while the air that is not in contact with the earth surface remain warmer. As a result, as when you are moving from here to here, what will happen? Temperature will increase, and this type of temperature inversion is called as a ground or surface type of temperature inversion. Fine. The third type of temperature inversion that you have is a frontal type of temperature inversion. Done. So third type is frontal type of temperature inversion. Now what happens in this type of inversion? This inversion occurs wherever you'll see wherever you'll find convergence of two contrasting winds. Fine. So this type of temperature inversion you're going to find in which region? You're going to find in those regions where you see convergence of two contrasting winds. Fine. What is contrasting wind means? Two different winds in terms of air mass. Any other thing? Yeah. Two different type of wind in terms of temperature, in terms of pressure, in terms of humidity. Clear? So what you see is, okay, when two different type of temperatures are going to converge, clear, two different type of air are going to converge or contrasting winds are going to converge, then it is called as a frontal type of temperature inversion. Generally one could be warm wind and another could be cold wind. So warm wind generally have which type of pressure? Low pressure. Cold wind generally have which type of pressure? High pressure. So you'll find different type of pressure or different type of temperature that you find with regard to this type of inversion. Clear? So let's say this wind is coming, this wind is coming, is a warmer wind. This is a warmer wind. And the wind, this wind that is coming over here is a colder wind. When these two winds will meet, what will happen? When these two winds will meet, what will happen? Warmer?
The wind becomes warm.
The wind becomes warmer. Any other thing?
And then the wind warmer will rise up and the colder will stay in the
Yeah. What you see is okay. Warmer wind means what? As we discussed, less dense. This is going to be less dense. Colder wind means what? More dense. Clear? Because colder wind contract, their volume is low. Volume is low means what? It is going to be more denser. It is going to expand. Expand means what? More volume. More volume means what? Less dense. So whenever warmer wind and colder wind will come together, you will find less dense wind and you will find more dense wind that are coming together. Clear? And whenever you know that principle we have discussed, what will happen? Less dense will float over what? More dense. Less dense will float over more dense. So as a result, you will see warmer wind is going to be what? You will see warmer wind are going to rise up like this. They are going to be rise up like this. So this is how you see warmer wind are rising up, and you will see colder wind like this. So this is less dense will go up over more dense. Less dense will go up over more dense. When this wind will go up, what will happen? What will happen? You will see what? You will see here which type of wind are there? Colder condition. Here which type of wind are there? Warmer. So as you are moving from here to here, what is happening? Temperature inversion is happening. So what you are happening is temperature inversion is happening, because this is colder layer, this is warmer layer. So as you are moving from here to here, what is happening? This temperature is increasing from colder to warmer you are moving. So temperature is increasing. This phenomena is referred as what? This phenomena is referred as a frontal type of temperature inversion. Fine. So these are the three different type of temperature inversion you are finding. Air drainage generally you are finding where? Air drainage generally you are finding where? Mountain areas. Why? Which type of condition need to be there? Which type of condition need to be there? Valley should be more colder than what? More colder than the mountain slope. Then you'll see air drainage type of temperature inversion. What will happen in a ground or surface type of temperature inversion?
in light,
Yes.
and going up the temperature.
Fine. And what will happen in case of frontal temperature inversion? Two contrasting wind need to come, and two contrasting wind, when they are coming, what is going to be creating? It is going to be creating the temperature inversion, as warmer wind will rise up over colder wind. Fine. Where do you see this type of frontal type of temperature inversion? In equator, coastal areas. Anyone else? Where do you see? If you remember, we discussed which is a pressure belt, which wind is converging, northeast and southeast. Then we discussed this is which type of pressure belt? Subtropical high pressure belt. This is subpolar low pressure belt. Which wind is coming? Westerlies. Here which is there? Westerlies. Which is coming from here? Easterlies. Clear? So where do you see wind convergence? You are seeing wind convergence in equatorial region, where northeast trade wind and southeast trade wind are converging. Clear? So here you see convergence of wind that is happening. But here frontal type of temperature inversion will not be formed. Why it is not being formed? Why it is not being formed? Because both wind are hotter in nature. Both are coming from where? Tropics region. Both are hotter wind. Contrasting winds are required. Clear? Both are hotter wind, as both are. Tropic of Cancer also receives heat. Tropic of Capricorn also receives heat. So as a result, both are hotter winds. So northeast trade wind and southeast trade wind, both are hotter. When both are hotter, what will happen? Frontal inversion will not be formed. When westerlies and easterlies are meeting, what is happening? Easterlies are coming from where? From the polar region. So it is a colder wind. While westerlies are going from where? From the tropics region. So hotter wind. So when this type of conversion, this type of temperature inversion, you are seeing when westerlies are converging with whom? Easterlies. When westerlies are converging with the easterlies, you are going to see which type of temperature inversion? Frontal type of temperature inversion. Fine. So this is all about concept of temperature inversion. What is temperature inversion? As you go up, if temperature starts to what? Temperature starts to increase, it is called as a temperature inversion. Which conditions are required for temperature inversion? Long nights, winter weather, winter condition, stable weather, and calm air. Those four conditions are something that are required. Then we discuss three type of temperature inversion: air drainage, generally in mountain areas; surface temperature inversion, generally in ground or planar areas; and third we have written is a frontal type of temperature inversion, generally where you are going to see frontal in the region where westerlies and easterlies are meeting together. There you see frontal type of temperature inversion. Fine. Next comes your concept of humidity. What is humidity now? It is simply it is moisture or water vapor present in the air is called as what? Is called as humidity. Water vapor or moisture present in air is called as humidity. Fine. Now, water vapor plays a very important role. Why it plays a very important role? Water vapor plays a very important role. Why it plays a very important role? Water vapor plays a very important role. Why? We discussed it absorbs also incoming light and incoming solar radiation. It also absorbs outgoing solar radiation. Remember heat budget? We discussed 14 unit is absorbed from the incoming radiation and 34 unit is being absorbed from what? Outgoing radiation. So if you remember heat budget, we have discussed this particular part. So what is absorbing? Remember transparency of atmosphere we have discussed. Radius, if okay, what incoming solar radiation wavelength is greater than radius of obstructing particle, equal to radius of obstructing particle, and less than the radius of obstructing particle. So we discuss reflection, absorption, or scattering will takes place. So that part we have discussed. So water vapor is okay playing an important role in absorbing incoming solar radiation also and outgoing solar radiation also. Fine. And also it determines what? It determines the rainfall, clouds formation, how cloud is going to form, how rainfall will happen. All this depends upon what? All this depends upon water vapor. So what is humidity? Humidity simply can be defined as what? The water vapor or moisture that are present in the air, that is called as what? That is called as a humidity. Fine. Primarily, we have three different type of humidity. We measure humidity in three different type. One is called as an absolute humidity. Second is called as a relative humidity. And the third is called as what? The third is called as specific humidity. So primarily you have three different type of humidity: absolute humidity, relative humidity, as well as specific humidity. Fine. So when you are getting a news bulletin, you see, have you observed any weather bulletin and etc., or have you seen any app and etc.? Their humidity is something that is mentioned. Clear? So if you have any weather related app today, you check it. Okay, what will be mentioned? Wind speed will be mentioned, or the humidity concentration will be mentioned. It is generally mentioned in the form of percentage. Humidity is generally going to be measured. Humidity is generally going to be represented in the form of percentage. That is okay there. Clear? For example, so what you are finding, you can see precipitation 40% chances it is showing. Humidity, how much chances showing? Humidity is 80%. Wind is how much? Wind speed is mentioned, air quality is mentioned. So generally you see weather reports, you will find these parameters are something that are going to be mentioned. What is the wind speed, what is humidity, what is chances of rain and etc., what is air quality? Those reports are something that you are going to find in the app. So here humidity is something that is okay, mentioned in what? Mentioned in percentage. Which type of humidity is reflected over here, whether absolute humidity, whether relative humidity, or whether specific humidity? What we are measuring when we are writing over humidity over here?
Relative.
It is a relative humidity. Yes. Okay. So humidity, whatever you are seeing in the form of in the news bulletin, etc., those humidity is which type of humidity? Relative humidity. So remember that humidity can be measured in what? Humidity can be measured in three different aspects, which are referred as what? Absolute humidity, relative humidity, as well as what? Specific humidity. It is measured in three forms. Fine. What is absolute humidity? It is defined as the actual amount of water vapor, that is present in air. Actual amount of water vapor that is present in air is called as what? Is called as a absolute humidity. Fine. And it is measured as what? It is measured as a weight of water vapor, present in per unit volume of air. So weight of water vapor present in per unit volume of air. This is how we are trying to measure the absolute humidity. Fine. So that's why absolute humidity formula is how we measure the absolute humidity. Weight of water vapor in gram divided by volume of air in meter cube. Fine. So absolute humidity, what the term absolute means? Absolute means how much actual amount of water vapor that are present. That is called as the absolute humidity. How we calculate absolute humidity? It is weight of water vapor present in per unit volume of air. So weight of water vapor you are measuring in which? Gram, and volume of air you are measuring in which one? Meter cube. So unit of absolute humidity is what? Gram per meter cube or gram per centimeter cube. Generally you can measure that. Fine. Fine. Now remember that absolute humidity is going to vary with whom? Vary with temperature. It is going to vary with the pressure. So absolute humidity is going to vary with whom? Absolute humidity is going to vary with the temperature. It is also going to vary with whom? vary with the pressure. Why it will vary? Why it will vary? Because just now we discussed warm air. If air is going to be warm, then what will happen? Warm air, volume will what? Expands. Anything heated, volume will what? Expand. When volume expand, what will happen? More amount of moisture it can hold, because it has more volume. Then cold air is what? Cold air has less amount of volume, so it can hold what? It can hold less amount of moisture. Fine. So what you see is absolute humidity is going to vary with what? Vary with the temperature. Warm air have more volume. More volume means what? It can expand, it can hold more amount of moisture, while cold air, less volume, contraction is happening. So what will happen? It can hold lesser amount of water vapor. Clear? What about pressure? High pressure means what? High pressure means what? Volume will be more or volume will be less? Remember, we discussed Charles' law. Volume is directly proportional to temperature. Boyle's law, volume is inversely proportional to what? Pressure. If high pressure are there, then what will happen? You are compressing. I am applying high pressure means what? I am compressing things, that is okay there. So volume will decrease. When volume will decrease, what will happen? Less amount of water vapor. Low pressure means what? Expansion. Low pressure means expansion. As a result, what will happen? You'll see more amount of water vapor it can hold. So absolute humidity is going to vary with whom? Going to vary with temperature and pressure. Absolute humidity is not constant. It is not constant. It will vary with temperature as well as pressure. Fine. Any doubt regarding this particular thing? So what is absolute humidity? It is actual amount of what? It is actual amount of water vapor present in the air. How do you measure absolute humidity? Weight of water vapor in gram divided by what? Volume of air. And what you see is okay, temperature and pressure, through which these are the one which are deciding how much moisture a air can hold. Clear? Temperature and pressure are the one which are deciding how much moisture the air can hold. Warm air can hold more moisture, cold air can hold lesser moisture. So what is deciding how much moisture an air can hold? Temperature and pressure are something that are deciding how much moisture a air can hold. Fine. Any doubt regarding this particular part? Now, one more thing. There are two types of air. One is called as a saturated air, and another is called as a unsaturated. So there are two types of air. One is called as a saturated air, another is called as a unsaturated air. Saturated air means what? Saturated air means the air has hold all moisture. It can't further hold moisture. Clear? All air is holding moisture, but it can't further hold the moisture. Then it is going to be called as what? Saturated air. If air can still hold moisture, then it is going to be called as what? Unsaturated air. Clear? Just now we discussed what is humidity. Bangalore weather we have discussed. What is humidity? 80%. Means it can further hold how much moisture? 20%. So currently air is what? Unsaturated. If humidity becomes 100%, then what will happen? It becomes saturated, because air further cannot hold any moisture. Fine. So there are two type of air also, saturated air and unsaturated. Unsaturated means air can still hold moisture. Saturated means air cannot hold moisture. Air cannot further hold moisture. Fine. So that difference you have to keep in mind with regard to saturated and unsaturated air. Fine. So we'll start with relative humidity and specific humidity in tomorrow's class, and then we'll discuss the cloud, weather, rainfall. So those things we'll cover in tomorrow's class. Fine. Any doubt regarding this one? So remember the classification of wind: seasonal wind and periodic wind. Seasonal winds are what? Southwest monsoonal wind and northwest monsoonal wind. Periodic winds are what? Mountain and valley breeze and land and sea breeze. They are also referred as mountain and valley breeze can also be called as a katabatic and anabatic, depending upon descending or ascending. And you have onshore wind and offshore wind also. Fine. Then you also have cold local wind. Then we discuss what? Temperature inversion, type of temperature inversion, air masses, continental air mass, polar air mass, and continental air mass, polar air mass, you are dividing this based on what? Source of origin, whether they are originating in tropics or whether they are originating in what? Polar region. Fine. And lastly, you have concept of what? Humidity. Remember what is humidity and what is absolute humidity. One more thing, the instrument which is being used to measure humidity is called as a hygrometer. So instrument that we are using to measure humidity is referred as what? Is referred as a hygrometer. Fine. So this instrument we are using to measure the humidity. How we are saying 80% humidity? So we are measuring it with an instrument which is referred as what? Hygrometer. Fine. Any doubt? Thank you. Thank you for today.